standard deviation should be one fewer order of magnitude than your mean. So basically, what this means, so what does this mean? This is kind of confusing, but what this means is that, so let's say we have the number 3 and the number 7. They're both in the ones place, so they have the same order of magnitude because they're both in the ones place. And then let's say we have the number 15 and the number 4. Well, they have a different order of magnitude because the 15 is in the tens place, the 4 is in the ones place. So here we have two examples. Let's say your standard deviation is 0.1 and then your x-bar or your mean is 0.5. That does not fit the criteria we just talked about, so that means you did a pretty bad job on your lab. But if your standard deviation is 0.1 and if your mean is 500, then you actually did an amazing job on your lab and your data is pretty strong. So let's talk about standard error. So using standard deviation, that helps us find the standard error. The standard error is also called the standard error of the mean, and it can be calculated with this formula. So you're doing standard deviation divided by the square root of n, which is our number of data points. So standard error tells us the deviation from the mean, the frequency of deviation, and takes into account the size of the data. And because you're using n, you are taking into account the frequency and the size of the data. So ideally, in any experiment or lab, you want an infinite amount of data points, because if you only have like 5 data points, then how do you know if those data points are like skewed or biased or whatever? But if you have infinite data points, you have the perfect sample size. Everything kind of comes under that sample. It's unbiased. It's kind of like the perfect unrealistic experiment sample size. So ideally, you actually want infinite amount of data points, but the standard error tells us how close you are, how close your calculated mean is from the true mean. So your true mean is the mean calculated if you had an infinite amount of data points. So it tells you how far your actual mean is from the true mean. So error bars. So error bars show the variance in a data point, and it kind of shows the mean variance. And I know what some of you might be thinking, oh, this sounds a lot like standard deviation. Well, it's using standard error, and if you remember, standard error uses standard deviation. So in a way, this is kind of using standard deviation. It's kind of like a glorified version of standard deviation. So it shows the variance in a data point. It shows the mean variance. And this is calculated by adding and subtracting the standard error from each data point. So if we have in our example here, this should be adding and subtracting the standard error from the mean. That's what it should have been. So if we have a sample graph here, maybe this is a poll of who likes vanilla ice cream better than chocolate or chocolate better than vanilla. Our mean is 35 for the chocolate side, so that's right here. And then we plus or minus the standard deviation, and then we get our error bar, which kind of looks like this I at 45, because our standard error is 10. So 35 plus 10, 45, minus 10, that's 25. So 25 will be here, 45 will be here. And then we have this range right here. That gives us our I shape. Same with vanilla. Our mean is at 15. That's what our x-bar shows us. And then our standard error, which is represented by SE, is 7. So we're adding and subtracting that from the mean. So we have 22 and then 8. Oh, and by the way, this is very important for the AP Bio test. So if you had been zoning out this entire video, this is actually very important to know, because I'm pretty sure I had this on my FRQ, and this comes up a lot on FRQs, and oftentimes you have to make a graph and then show the error bars, and sometimes it's not always plus or minus 1 standard error, so it's plus or minus 2 standard errors. So for like instance, this would be at 55, and then this would be at like 15. So sometimes you have to read the directions carefully about how many plus or minus standard errors you want for each error bar. But error bars are very important, and it's tested a lot on the AP Bio test. And also your ability to graph a bar graph and just graphs in general is tested a lot. Don't be like me, because this was just for teaching purposes. I got kind of lazy with the X and Y axis. You're definitely going to want to scale your Y axis better than I did. And you're going to want to have a title for your Y axis, your X axis, and your overall title of the graph. So why is it important to have error bars? Well, error bars are actually important because they tell us if the two means are statistically different. If there is no error bar overlap, we consider the two means to be statistically different. So if you look here, there's no overlap because we end at 22 and we start at 25. So these error bars, they do not overlap. So they are statistically different means. But if I were to add like a third category, let's say this is like strawberry ice cream. And this was our error bar. It looks something like this. Yeah, these means would have no statistical difference between the 2 points because the means overlap. Because the error bars overlap. We have a lot of overlap space here and a lot of overlap space here. So we have all this overlapping, and that tells us if the i's, aka the error bars, overlap, that tells us that our means are not statistically different. And that's a very important concept that you see tested a lot on the AP Bio test, especially on the AP Bio FRQs. So yeah, that's Biostatistics. Thank you for watching, and stick around more for some announcements. Announcement number 1 is that if you're not subscribed, then you should already subscribe to our YouTube channel, because I looked at the YouTube analytics page and it said that over 80% of the people that watch these videos are not subscribed. So if you're stalking our YouTube channel by watching all of our AP Bio videos without subscribing, then shame on you. You should just subscribe while you're at it. And another common question that I get is how to get a 5 on AP Biology. So on our Instagram, we're posting AP Biology study tips. And basically, we have former AP students that have gotten a 5 on the AP Bio test. They submit tips on the researches they use to study, the resources they use to study, the tips for multiple choice, and tips for FRQ. So thank you to all the SNHS members that submitted these study plans and these study tips. They're very helpful, and they're posted on our Instagram, so make sure to check that out. And we're not just doing that for AP Bio. Later, we're going to post one for AP Chemistry, AP Physics, AP Computer Science, and yeah, that's it. So if you know any of the friends that are taking those AP Sciences, definitely share that link to them once it's posted, which is going to happen pretty soon. So make sure to check out our Instagram, follow us on Instagram, and also subscribe. Okay, bye.